On April 23, 2004, in Gibraltar, Michigan, a maintenance worker on a traveling carnival died due to an improperly locked out and tagged machine. Another employee, unaware that the machine was being serviced, turned it on, killing his co-worker. OSHA regulations generally prohibit working on energized electrical equipment unless certain exceptions apply. These exceptions typically require that the employee be qualified to work on energized equipment, that the work be conducted in accordance with specific safety procedures, and that the equipment be properly de-energized when it is not being worked on. Considering the arguments for and against working on live equipment, some tasks cannot be performed safely without working on live equipment. Energizing equipment can be time-consuming and disruptive to operations. Qualified electricians are trained to work safely on live equipment. Conversely, working on live equipment is inherently dangerous and significantly increases the risk of electrical accidents. Even qualified electricians can make mistakes. The potential consequences of an electrical accident are severe, including death or serious injury. The decision of whether or not to work on live equipment should be made on a case-by-case basis, considering the specific circumstances and the potential risks involved. Qualified electricians should follow all applicable OSHA regulations and industry best practices to minimize the risk of electrical accident. In cases where it is necessary to work on live equipment, strict safety protocols should be followed, including lockout/tagout procedures, use of appropriate personal protective equipment, proper training and supervision, and adherence to established safety guidelines. Electrical safety is paramount in any work environment, and a thorough understanding of lockout/tagout procedures is essential for preventing accidents. Lockout/tagout, often abbreviated as LOTO, is a safety procedure used to ensure that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or repair work. It requires that hazardous energy sources be isolated and rendered inoperative before any work is started on the equipment. The process involves affixing a lockout device, typically a lock, to an energy isolating device, such as a circuit breaker or valve, and attaching a tag to the lock that identifies the worker performing the maintenance and the reason for the lockout. The basic principles of lockout/tagout involve several key steps. Firstly, prepare for shutdown, which includes identifying all energy sources that need to be controlled and understanding the equipment's operating procedures. Secondly, shut down the equipment using the normal operating procedures. Thirdly, isolate the equipment from all energy sources by disconnecting or deactivating the energy isolating devices. Fourthly, apply lockout/tagout devices to each energy isolating device to prevent accidental re-energization. Fifthly, safely release or restrain any stored energy, such as that in capacitors, springs, or elevated machine parts. Sixthly, verify that the equipment is effectively isolated and de-energized before starting work. This can be done using test equipment to confirm the absence of voltage or pressure. Understanding the different types of energy sources is crucial for effective lockout/tagout. Electrical energy is one of the most common hazards, requiring the use of circuit breakers, disconnect switches, and other electrical isolation devices. Mechanical energy can be stored in moving parts, springs, or pressurized systems, requiring the use of blocks, supports, and other mechanical restraint. Hydraulic energy involves pressurized fluids, requiring the use of valves and other hydraulic isolation devices. Pneumatic energy involves compressed air or gases, requiring the use of valves and regulators. Thermal energy involves heat or cold, requiring insulation and cooling or heating procedures. Gravity can also be a form of energy, especially with suspended loads, requiring the use of supports and safety cables. Personal protective equipment, or PPE, plays a crucial role in electrical safety and complements lockout/tagout procedures. Common PPE includes insulated gloves, which protect against electrical shock when working near energized equipment. Safety glasses or face shields protect the eyes and face from arc flashes and flying debris. Flame-resistant clothing protects against burns from electrical arcs and thermal hazards. Hard hats protect against head injuries from falling objects or accidental contact with equipment. Safety shoes protect against electrical hazards and physical injuries to the feet. The Occupational Safety and Health Administration, OSHA, provides comprehensive regulations and guidelines for lockout tagout, specifically outlined in 29 Code of Federal Regulations 1910.147. These regulations cover the control of hazardous energy sources and aim to protect employees from unexpected energization or startup of machines or equipment during service or maintenance activities. OSHA requires employers to develop, implement, and enforce a written lockout tagout program that includes specific procedures for isolating energy sources, applying lockout tagout devices, and verifying isolation. The regulations also mandate employee training on the purpose and function of the lockout tagout program and the specific procedures required for their job tasks. Employers must also conduct periodic inspections of their lockout tagout procedures to ensure they are being followed correctly and effectively. OSHA's regulations emphasize the importance of clear communication, proper training, and consistent enforcement to prevent accidents and injuries related to hazardous energy. Qualified electrical workers play a critical role in ensuring electrical safety and implementing lockout tagout procedures effectively. A qualified person is defined by OSHA as someone who has the skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Qualified electrical workers are responsible for identifying potential electrical hazards, assessing risks, and implementing appropriate safety measures. They must be trained in the proper use of test equipment, personal protective equipment, and lockout tagout procedures. Qualified electrical workers are also responsible for verifying that equipment is properly de-energized and grounded before starting any work and for ensuring that lockout tagout devices are correctly applied and removed. Ongoing training and competency assessments are essential to ensure that qualified electrical workers maintain their skills and knowledge and remain up to date on the latest safety standards and procedures. Common electrical hazards include electrical shock, which occurs when a person comes into contact with an energized conductor and the current passes through their body. The severity of the shock depends on the voltage, current, and duration of exposure. Arc flash is a dangerous condition that can occur when a high-voltage electrical discharge creates a sudden release of energy in the form of heat, light, and pressure. Arc flashes can cause severe burns, blindness, and even death. Electrical fires can be caused by faulty wiring, overloaded circuits, or damaged equipment. These fires can spread quickly and pose a significant threat to people and property. Electrocution, or death by electrical shock, is a severe hazard that can occur when a person comes into contact with a high-voltage electrical source. The risk of electrocution is especially high in wet or damp environments. Electrical burns can result from contact with energized conductors or from arc flashes. These burns can be severe and require immediate medical attention. To mitigate these hazards, several strategies can be employed. Firstly, regular inspections and maintenance of electrical equipment can help identify and correct potential problems before they lead to accidents. Secondly, proper grounding of electrical systems can help prevent electrical shock by providing a path for fault currents to flow safely to ground. Thirdly, the use of ground fault circuit interrupters, or GFCIs, can help protect against electrical shock by quickly disconnecting power to a circuit when a ground fault is detected. Fourthly, the use of arc flash protection, such as arc-rated clothing and equipment, can help reduce the severity of injuries from arc flashes. Fifthly, employee training on electrical safety and hazard awareness is essential for preventing accidents and ensuring that workers know how to respond to electrical emergencies. Lockout tagout procedures are a critical component of electrical safety and are designed to prevent accidents during maintenance and repair activities. The basic steps of lockout tagout include preparing for shutdown by identifying all energy sources and understanding the equipment's operating procedures. Shutting down the equipment using the normal operating procedures. Isolating the equipment from all energy sources by disconnecting or deactivating the energy isolating devices. Applying lockout tagout devices to each energy isolating device to prevent accidental re-energization. Safely releasing or restraining any stored energy. Verifying that the equipment is effectively isolated and energized before starting work. Key elements of an effective lockout tagout program include a written lockout tagout procedure that clearly outlines the steps to be followed for each piece of equipment. Employee training on the lockout tagout procedures and the hazards associated with energized equipment. Regular inspections and audits of the lockout tagout program to ensure it is being followed correctly and effectively. Proper identification and labeling of energy isolating devices. Use of standardized lockout tagout devices that are durable and easily recognizable. Clear communication between employees to ensure that everyone is aware of the lockout tagout status of equipment. When performing electrical work, several safety precautions must be followed to minimize the risk of accidents. Firstly, always energize equipment before starting work whenever possible. Secondly, use appropriate personal protective equipment, including insulated gloves, safety glasses, and flame-resistant clothing. Thirdly, inspect tools and equipment before use to ensure they are in good working condition. Fourthly, maintain a safe working distance from energized parts. Fifthly, use insulated tools when working near energized equipment. Sixthly, never work alone on electrical equipment. Seventhly, be aware of the potential for arc flash and take appropriate precautions. Eighthly, follow all applicable safety regulations and procedures. The process of risk assessment is a critical component of electrical safety and involves identifying potential hazards, assessing the likelihood and severity of potential accidents, and implementing control measures to reduce the risk. The steps involved in risk assessment include identifying potential hazards by conducting a walkthrough of the workplace and reviewing accident reports and safety data sheets. Assessing the likelihood and severity of potential accidents by considering factors such as the frequency of exposure, the potential for injury, and the potential for property damage. Implementing control measures to reduce the risk by using engineering controls, administrative controls, and personal protective equipment. Engineering controls involve modifying equipment or processes to eliminate or reduce hazards. Administrative controls involve implementing procedures or policies to reduce the risk of accidents. Personal protective equipment involves providing employees with equipment to protect them from hazards. Regularly reviewing and updating the risk assessment to ensure that it remains current and effective. The principles of electrical grounding are essential for preventing electrical shock and ensuring the safe operation of electrical equipment. Grounding provides a low resistance path for fault currents to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. Grounding also helps to stabilize voltage levels and reduce electrical noise. The National Electrical Code, or NEC, provides detailed requirements for electrical grounding, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for grounding different types of equipment. Ground fault circuit interrupters, or GFCIs, are a critical safety device that can help prevent electrical shock by quickly disconnecting power to a circuit when a ground fault is detected. GFCIs work by monitoring the current flowing through the hot and neutral conductors of a circuit. If there is a difference in current between the two conductors, it indicates that some of the current is leaking to ground, which could be through a person's body. When a GFCI detects a ground fault, it trips the circuit in a fraction of a second, preventing a potentially fatal electrical shock. GFCIs are required in many areas of the home and workplace, including bathrooms, kitchens, garages, and outdoor locations. Arc flash hazards are a significant concern in electrical safety and can result in severe burns, blindness, and even death. An arc flash is a dangerous condition that can occur when a high-voltage electrical discharge creates a sudden release of energy in the form of heat, light, and pressure. Arc flashes can be caused by a variety of factors, including accidental contact with energized parts, insulation failure, and equipment malfunction. To protect against arc flash hazards, employers must conduct an arc flash hazard analysis to determine the potential for arc flash and the level of protection required. Employees must wear appropriate arc-rated clothing and equipment, such as arc flash suits, gloves, and face shields. Employers must also implement safe work practices such as de-energizing equipment before starting work and maintaining a safe working distance from energized parts. Emergency response procedures are a critical component of electrical safety and should be in place to address potential electrical accidents and emergencies. Emergency response procedures should include steps for reporting electrical accidents, providing first aid to injured workers, and shutting down electrical equipment. Employees should be trained on the emergency response procedures and should know how to contact emergency services. Emergency response equipment, such as fire extinguishers and first aid kits, should be readily available in the workplace. Regular drills and simulations should be conducted to ensure that employees are familiar with the emergency response procedures. Electrical safety training is essential for all employees who work with or around electrical equipment. Electrical safety training should cover topics such as electrical hazards, lockout tagout procedures, personal protective equipment, and emergency response procedures. Training should be provided by a qualified instructor and should be tailored to the specific job tasks and responsibilities of the employees. Training should be conducted regularly and should be updated to reflect changes in safety regulations and procedures. Electrical safety audits and inspections are a valuable tool for identifying potential hazards and ensuring that electrical safety procedures are being followed correctly. Audits and inspections should be conducted by a qualified person and should cover all aspects of electrical safety, including equipment, procedures, and training. Audit findings should be documented and used to develop corrective actions to address any identified hazards. Regular audits and inspections can help prevent electrical accidents and ensure a safe working environment. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation and maintenance of electrical systems. The NEC is updated every 3 years and provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. Compliance with the NEC is essential for ensuring the safety of electrical systems and preventing electrical accidents. State and local jurisdictions often adopt the NEC as law, making compliance mandatory. Continuous improvement in electrical safety is essential for preventing accidents and ensuring a safe working environment. Continuous improvement involves regularly reviewing and updating electrical safety procedures, providing ongoing training to employees, and implementing new technologies and best practices. Continuous improvement also involves actively seeking feedback from employees and using that feedback to identify and address potential safety concerns. By continuously improving electrical safety, employers can create a culture of safety and prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. By following safe work practices, using appropriate personal protective equipment, and being aware of potential hazards, we can all help prevent electrical accidents and injuries. If you are not qualified to work on electrical equipment, do not attempt to do so. Contact a qualified electrician to perform any electrical work. And always remember to energize equipment before starting work whenever possible. Be vigilant, be prepared, and be safe.